All right, last day in the packet. So on this, we're introducing to new concepts we hadn't talked about so far in the packet, which is linear velocity and angular velocity. So if you imagine an object traveling along a circular arc, or like you running around a track or something like that, or NASCARs running around a race, the element of time is now added into the equation. So in order to do problems in such situations, we need to identify variables that can express certain information. So before we do, talk about linear velocity and angular velocity. So linear velocity is a type of velocity that you're probably used to, which is how quickly an object's position is changing. All right. And then angular velocity is how quickly an object's angle is changing. All right. So some important variables for problems in which an object is moving along a circular arc are these below. And we've talked about almost all of them, but not yet. Well, maybe not. We've talked about half of them. So R is the radius, obviously. It needs to be linear units like inches, feet, things like that. Theta is the angle. It can be given as degrees, radians, or revolutions. So then you have some examples of that. So this one right here, where it's just 1.5, that's 1.5 radians for sure. Doesn't have to have a pi to be radians. All right, and then S is the arc length. It's also linear units, like feet or centimeters. All right, so T is time. Time is going to be given in time units, like seconds, hours, minutes. Then V is a new one for today, and it's linear velocity. And it's going to be linear units over time. So like 5 feet per second. 12, and then this MPH you'll see a lot, which MPH, I think everybody knows, just to make sure, it's miles per hour. All right. And then angular velocity is the new one. It's omega. This is a Greek letter, omega. And omega is going to stand for angular velocity. And it's going to be given in angular units over time, like 15 degrees per second. And then RPM. RPM is an angular velocity, and you've probably heard of it because most of you drive cars. But RPM stands for revolutions per minute. Okay. So on 12, I want you guys to take a second or two, or more than seconds, but each one of those variables, radius, angle, arc length, time, linear velocity, angular velocity, is going to be used one time. So read through those and decide which is which. So if what's given is a radius or an angle, so you guys decide that. Go ahead and pause the video, and then when everyone's done, start it back up, please. All right, so space shuttle making orbits. An orbit is like a revolution. A revolution is an angle, so that's going to be a theta. And then I walk 10 minutes along the rim. So the only given thing in here is time. 10 minutes is time. A satellite is circling the Earth at that miles per hour. Miles per hour is always going to be a linear velocity. The spoke of a wheel is going to be a radius. Around the world in 80 days, so that you're completing a rotation or a revolution in 80 days. So that's an angular velocity. And then a circular track measures 400 feet. That is an arc length. All right, so I hope you guys did well on that. So these problems, we're going to have to do a whole lot of dimensional analysis, and you may or may not so you may or may not be super comfortable with this. I'll try to go slow. I'll definitely keep talking about this when I get back. But angular and linear velocity, they're related. So when an object is traveling along an arc, it has both linear and angular velocity. So this formula ties the two variables together, and it's that v equals omega times r, or the angular velocity times the time. Now, the angular velocity should be in radians per time. R is measured in linear units, and V is measured in linear units over time. Now, just like the arc length formula, it was S equals R theta. This one is, we can do it in a similar way where we can do that T thing. All right, the top is going to be the linear velocity, and then the bottom two are going to be omega and r. So we can use that to find any of these. So you're either multiplying or dividing here. All right, to solve these types of problems and give the answer in correct units, you must multiply by fractions that are equal to 1. Here are examples, and their reciprocals work well, and then there are tons of other examples of these. So because there's 12 inches in a foot, we can multiply by 12 inches over 1 foot. It doesn't change the value, it's just going to change the units. Or we could do it the other way, 1 foot over 12 inches. It just depends on what you want to cancel and where it's located. All right, so let's jump into these. So for example 3, a bicycle wheel has a diameter of 30 inches. I said that weird, but that's okay. If the wheel makes 1.5 revolutions per second, find the speed of the bike in miles per hour. All right, so we know the diameter, which means we also know the radius. All right, and then it tells you that the wheel makes 1.5 revolutions per second. That is an angular velocity. Now, whenever to do this, to make it work, whenever we have a unit like revolutions per second, we need to write it as revolutions over seconds, or that will help us cancel what we need to cancel. Now we want to give this linear velocity in miles per hour. So let's start with what we're going to do. So if we're looking for V, according to our formula, we're going to multiply omega times r, or the angular velocity, times r. Now, that isn't a fraction, so I'm just going to put it over 1 just to keep everything normal. Now, if I multiply this, I would get whatever revolution inches per second, which is not what we want. We want miles per hour. So we have to change all of our units. So first, let's think about the revolutions. In linear velocity, this is important. In linear velocity, there is no angle measurement. It's just a linear and a time. So we have to completely get rid of angle units. And so that means the only angle measurement that doesn't have a unit is radians. So I need to change revolutions to radians. So since this revolution is in the numerator, to cancel it, I'm going to put revolutions in the denominator. All right. And then I want to change it to an angle measurement, or to a type of measurement that doesn't have a unit, which is radians. And so 1 revolution is how many radians? It's 2 pi. All right, that's what we wanted. So now these revolutions cancel. You now have inches per second. So if the question if they wanted you to give the answer in inches per second, you would. But we don't. We want miles per hour. Okay, so we've taken care of the revolutions. Now we're just going to pick one and take care of it. So let's just pick seconds. Let's take care of seconds. Now, some of you may know how many seconds are in an hour. If you don't, it's okay. I know you know how many seconds are in a minute. And so there are 60 seconds in 1 minute. Seconds was in the denominator. So if I want to cancel it, I'm going to have to put seconds in the numerator. So 60 seconds in 1 minute. All right. And that is going to cancel seconds. All right. So now we have inches per minute. We're not there yet. We're getting a little closer. All right. So we want miles per hour. So I know there are 60 minutes in 1 hour. Do you guys know why I chose to write it that way and not 1 hour over 60 minutes? I hope so. Because we want to cancel minutes. Minutes was in the denominator. Multiplying it by minutes in the numerator cancels minutes. All right, getting a little closer. So now we would have our answer in inches per hour. So we got hours. Now we need to change inches to miles. Now I personally do not know how many inches are in a mile, but I do know how many inches are in a foot. And I also know that since inches is in the numerator here, I'm going to want to put inches in the denominator here. So I know that there are 12 inches in 1 foot. All right, and then that will cancel inches. So now I have feet per hour. Now, if you don't know it, I want you to know it. You got one up here. There are 5,280 feet in 1 mile. Now, I don't want that fraction because I want feet to cancel. So I just want the reciprocal of that fraction. So I want to cancel feet. So 5,280 feet is going to go in the denominator, cancel that. That's going to be 1 mile. Feet cancel. All right, so our answer would now be in miles per hour, exactly like I wanted it. Okay, now I highly encourage you on a test or a quiz on this to write all that out, because I'll look at your work. Using those calculators that are not very smart, it's really easy to mess this up. But what I'm going to do is I'm going to go through, and if it is in the numerator, I'm going to multiply by it. If it's in the denominator, I'm going to divide by it. All right, so let's see if I can do this without messing up. So we're going to do 1.5 times 15 times 2 pi, which is times 2 times 3.14 times 60 times 60 divided by 12 divided by 5,280. Fingers crossed to everybody. That is not what I got before. Oh, it's fine. I think I messed it up before. All right. I'm just going to trust it. You guys let me know later if it wasn't right. So it's going to be 8.69, and then our unit, remember we have miles left over in the numerator, so miles per, and hours left over in the denominator, miles per hour. Yeah, so it's a pretty normal speed for a bike. What I had before when I did it earlier was not. Okay, let's look at example 14. A centrifuge has test pilots traveling in a circular path very quickly in order to experience G forces. If the pilots are traveling 400 miles per hour and the circular room, not wrong, has a radius of 25 feet, find the number of rotations that the centrifuge makes per second. Okay, so we are given how fast this is traveling in miles per hour, so that is going to be a v. So miles per hour is always v, linear velocity. And then the circular room has a radius of 25 feet, that's going to be an r. So we want to find the number of rotations per second. That is finding angular velocity. So according to our formula, to find angular velocity, you're going to divide linear velocity by r. Now, because we have all these crazy fractions, instead of doing that, instead of dividing the linear velocity by r, what we're going to do is multiply the linear velocity by the reciprocal of r. And then all the work is going to come from getting it to be the right units. So 400 miles per hour needs to be written that way. And we're going to multiply that by 1 over the radius. So if you gave this as your answer, you'd be given the answer in miles per hour per feet, which makes no sense. So we're going to have to do some manipulating of the units. All right, so we want rotations per second. I'm probably instead going to call that revolutions per second. So we're doing angular velocity, we do not have a linear unit in our answer. So we need to cancel feet and we need to cancel miles. So you guys take a second and think about a fraction we could multiply by that cancels feet and cancels miles. All right, so feet was in the denominator is, now I want to cancel it, so I make sure I put feet in the numerator. So that's 5,280 feet. Miles is in the numerator. I want it to cancel, so I have to put 1 mile in the denominator. And that's awesome because that cancels miles and it cancels feet. So that's sweet. All right, and then the other thing I need to do is, right now that would mean I would have radians per hour as my angular unit. And what I want is revolutions per second. So let's go ahead and stick some revolutions in there. So revolutions is in the numerator, so I will want it to be in the numerator. And I'm basically canceling radians. So that's going to be 2 pi radians in the denominator. So no angular unit means it's radians. Okay, so that gives me my revs. Now I want to change hours to seconds. So if you know how many seconds are in an hour, go for it. Use that one fraction and be done. If you don't, it's okay. You do know how many minutes are in an hour. And you also hopefully know that because hours is in the denominator, I do need to put hours in the numerator. Okay, so that will cancel hours. And then I want to change minutes to seconds. So 1 minute is 60 seconds. Minutes cancel. So my final answer should be in revolutions per second, or rotations per second if you want to call it that. Okay, so here we go. Let's see how we do. Anything in the numerator, we multiply by. Anything in the denominator, we divide by. Now we're going to divide by 2, and then we're going to divide by pi. Might be better if we just do 2 or 6.28 there. Sorry, I talked in the middle of this. There's a good time I messed it up, but actually I didn't. I think I got it. So our angular velocity is going to be 3.74 rotations or revolutions per second. Ugh, that would make me so sick. It's one of the reasons why I can't be an astronaut or a pilot. All right, and then one more. And this is kind of tricky. It's short. It's shorter than the last one. The words are short, but it's kind of tricky. So the second hand of a large black clock is traveling at 2.5 inches per second. Find the length of the second hand. Now that didn't really tell you much, but that's definitely V. We want to find R. So that means there has to be an angular velocity somewhere. We can't find it. And there is. If you think about the angular velocity of a second hand on a clock completes one revolution in 60 seconds. So that's what I'm going to use for my omega. All right. According to my little formula, if I want to find R, I'm going to take my linear velocity and I'm going to divide it by my omega. But really, I'll write that down. But really what I'm going to do is take my linear velocity and multiply it by the reciprocal of omega. So this is R. Well, R's and V's look so similar, I don't want to confuse you. This is R. All right, so R is going to be 2.5 inches per second times the reciprocal of omega. So that's 60 seconds in one revolution. Okay, so what happens is seconds are going to cancel, which is good because there shouldn't be a time unit in a radius. But there also shouldn't be an angle unit. So this is 2.5 inches per revolution. Now that doesn't make sense for a radius. So I want to cancel revolutions. So I have to change it to a type of angle that has no unit because there is no angle unit in radius, and that is radians. So that's going to be 2 pi in the denominator. All right, so my revolutions are going to cancel. And it's going to be 2.5 times 60, which is 23.89 inches. That is a very large clock. Oh, I forgot. There's one I'm going to do that is in your homework section that I didn't put on the note sheet because when I printed the note sheet out, I wasn't completely sure about your assignment yet. But anyway, it doesn't matter. We're going to do this one together. And if you want to do it in this space up here, you can. Let's see if I can move it. Yeah, I can't move it, but you can do it in that space below day 3 assignment if you want to. Now, the reason I wanted to do this one is because it's asking you for different things. It doesn't give you a unit for your linear speed, so we're just going to do the easiest unit possible. But I think it's going to be way more beneficial for us if we do these second parts first and then go back and do the linear speed. So the angular velocity is already given to you in degrees per second. Let me rewrite that. But the second part, they want it to be in revolutions per minute. So let's just go ahead and do that. Let's change this to revolutions per minute. Okay, so we don't want degrees. So we would change degrees to revolutions. So because degrees is in the numerator, I need to put degrees in the denominator. How many degrees are in one revolution? 360. I hope you guys said that, or at least thought it. All right, so that is sweet because that is going to cancel degrees. All right, so now I have revolutions per second. RPM is revolutions per minute. So I need to change seconds to minutes. So I have seconds in the denominator. So to cancel it, I'm going to put it in the numerator. So that's going to be 60 seconds in 1 minute. And that will cancel seconds. And I'll be left with revolutions per minute, which is what I wanted. All right. So what we would do is 15 divided by 360 times 60. And when I did that earlier, I got 2.5 revolutions per minute. So that's one of your answers for 27. All right, 27 also wants us to find omega in radians per second. Okay, so I already have per second, so that's good. I don't have to change anything for that. But I want to change degrees to radians. And so degrees is in the numerator, so I'll cancel it. I'm going to put the degrees in the denominator. And changing degrees to radians, we've done every day, actually. You multiply by pi over 180, and that is going to cancel the degree. So then you're just going to multiply across the numerator. So that's 15 pi over, we can reduce 180, sorry. 15 over 180, 15 actually divides into 180 12 times. So this is going to be pi over 12 radians per second. I don't even like doing that radian. They wrote it that way, but I don't really like it. It's unnecessary. All right, now let's go back and do the first thing, which is find the linear speed. So if we're looking for v, we are just going to multiply omega times r. So we have 3 different omegas. And they're all the same, just a different unit. So we have 15 degrees per second, we have 2.5 revolutions per minute, and then we have pi over 12 radians per second. So think for a second, like which formula would be smartest to use in this problem when we want velocity. So we don't want any angle measurement. We only want a linear at a time. So you would always, if you're using a formula, you're always going to choose the angle measurement with radians. So I'm going to go ahead and do pi over 12 per second. You can write radians up there if you want to, but I wouldn't because it's not a unit. And I'm going to multiply that by my radius, which I don't remember what it was. 8 inches. That would just be over 1. Okay. And then I went ahead and did pi 3.14 divided by 12 times 8, and I got 2.09 inches per second. Now it didn't tell me a unit, so I just picked one. I'm just going to do it in inches per second. Now the book doesn't really like to give you a unit, so I'm going to give you one on number 29 because I need to know you can do it. Okay, so that was 27. All right, so what I want you guys to do for your assignment for day 3 is number 25, 26, 28, and 29. And then on number 29, it doesn't tell you, but I want you to give the answer in meters per second, please. That's just 4 problems. But one of them has several different things you have to do. All right. Hopefully I'll see y'all on Monday.